Hi everyone, Mr. Smith here, and we're recording our first lesson for the grade 11 functions course. In this lesson, we're going to review what a relation is. You've been working with relations at the very least since grade 9. You worked with linear relations in grade 9 and quadratic relations in grade 10. So we're going to review what a relation is, make sure we all have the skill of creating a table from an equation and a graph, and also look at some more types of relations that we're going to look at during this course. So let's get started. So first of all, let's review what a relation is. A relation is just a pattern, a relationship, a connection between two variables. And usually we use X and Y, but we can use other variables depending on the context if we want. A relation can be described 4 ways. I call this the rule of 4. A relation can be described with an equation, a written rule, a table, or a graph. So we're going to look at several examples looking at a relation these 4 ways. So here we go. Here's relation number 1. Now, ideally, this relation looks familiar to all of you, and you could even predict what this graph would look like and make a very detailed sketch of this graph. But if not, let's talk about what this equation says, generate a table of values, have a look. So this equation, y equals x plus 1, is saying that the y values of this relation are just 1 more than the x values. You take the x value, you add 1. So we can use that rule to make a table. Now, generally, if you're just making a table of values and producing a graph, like you can choose any x values you want. Often choosing values that center around 0, like from -3 to 3 is a good choice. But this isn't like, you don't have to do it that way. It's just what I've chosen to do here by default. And we're going to apply our rule and just add 1 to each of these x values. So -2, -1, -1 plus 1 is 0. And you can see the pattern here. We're just adding 1 each time. So this gives us 7 points that we could graph. -3, -2, -2, -1. And you can see the pattern on the graph as well. It's a straight line. This is a linear relation. That you guys spent a lot of time focusing on grade 9, worked a bit with in your grade 10 courses too. It's a linear relation with a slope of 1 and y-intercept of 1. And so after grade 9 and 10, you should be proficient in sketching lines given the equation. Read off the slope, read off the y-intercept, plot the y-intercept, and use the slope to get more points. So no surprises there. This is a linear relation. Let's look at our second one. So here's our second relation. Its equation is y equals x squared. So what is that equation saying? It is saying that the y values for this relation are the square of the x values. And so just using the standard -3 to 3, let's generate some y values. Remember that when you square something, you're multiplying it by itself, right? So that's -3 times -3 is +9. And even though you guys are taking the highest level of math in high school right now, the grade 11 functions course, if you're just getting started up again after a few months, I'm sure some of you guys may have plugged that in and got like -9. No, -3 times -3 is +9. When you square a number, you always get a positive, or in the case of squaring 0, you get 0. But you don't get negative numbers ever when squaring a real number. So we get that set of points. Plotting these guys, you'll see, hopefully this graph should be looking familiar from your grade 10 course. It is the basic parabola. That's not too bad. Missed that last point by a bit. This is the basic parabola, y equals x squared. It has a vertex of 0, 0, and it opens upwards. Maybe you talked about a step pattern in your grade 10 course. The step pattern for this particular parabola, from the vertex, you go over 1 and up 1, and over 1 and then up. Oh, I plotted it at the wrong spot. That should be at 4. Up 4, and then over 1. That's actually worth erasing. So I don't have my own editing team. So when I make a mistake, we're just going to roll with it. Or if somebody walks in the room, or if there's announcements going on. But yeah, up 3 and then over 1 and get to the next point, up 5. So this is a quadratic relation, the graph of which is a parabola. And again, this is something that we should be familiar with from our grade 10 course. Now, a lot of our first unit will actually be spent reviewing some skills with quadratic relations from your grade 10 course. So that's good. There's a lot of review built into our first unit, but that should be familiar to you. Let's continue. So the next few might not be familiar to you, and that's okay. That's kind of the intention. So we're kind of exploring some new types of relations that we might see this year, but also just, again, making sure we can all make a table of values and make a sketch. Also, you may not have used a calculator for a while. So what is this equation saying? Y equals 2 to the power of x. So this is saying the y values are powers of 2. So if you crank out 2 to the power of 3, and if you took the grade 10 academic course, which you guys all did, working with negative exponents is part of the grade 10 curriculum. Maybe you got to it, maybe you didn't. If you didn't, that's okay. We are going to spend a unit on exponential relations later on. For now, all I need for you to do is punch that into your calculator and get the value. So this, if you're in decimals, it will give you 0.125. If your calculator gave you 1/8, 1 divided by 8 is 0.125. We all got the same thing. 2 to the power of minus 2, 0.25. So if you'd like to pause the video and just make the table yourself and see what the graph looks like, that's fine. You can always have that flexibility to pause or fast forward if you just want to get the note down and you think you're good. But you can always just follow along with me as well. 2 to the power of negative 1 is 0.5. 2 to the power of 0 is 1. And then these are into the range where hopefully you can do these with mental math. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3, that's 2 times 2 times 2. That's 8. Now, what does this graph look like? So some of these points may be hard to graph accurately. That's okay. But like 0, 1, 1, 2, 2, 4, 3, 8, those are all easy. 0.5 is okay. 0.25, just do your best to draw 1.5. But yeah, this is what this graph looks like. It's pretty neat, just gets going faster, increases faster and faster, but going to the left, it gets smaller and smaller, but never quite reaches 0. So that's pretty cool. This is a new type of relation for you guys. This is called an exponential relation. And we'll spend a whole unit talking about these guys later on. All right, let's continue. So in your grade 10 course, you learned about trigonometry, sine, cosine, and tan. And something you might not have done is look at what happens if you plug in a bunch of different angles. Say here we're going from 0 to 540, but you could even continue farther and graph what the sine ratio is for those. What would the graph look like? So let's do that now. And as like the previous example, this is just to kind of see what we're doing this year. We'll spend a whole unit looking at these types of relations. Make sure your calculator is in degree mode. And to get the y values, we're simply doing the sine of the x values. So the sine of 0, when you punch in that into your calculator, you should get 0. When you punch in sine 90, you should get 1. Sine 180, you should get 0. Now, you guys have used the sine ratio in the context of triangles or acute triangles where the angles are actually in a triangle between 0 and 180. So it may seem weird to you to do the sine of even 180 or the sine of 270 because it's not possible in a triangle. But as we'll see, those calculations have meaning. What that meaning is, it's for a later time. All I need for you now is punch these values in and see what you get. should get negative 1 for 270, 0 for 360, back to 1 for 450, and 0 for 540. Now I'll plot those with you guys. Now, if we had plotted some in between, you would see it's not actually kind of like a Pikachu tail lightning bolt pattern. It's actually more of a smooth curve, like so. And this is what we call a periodic relation. And we're going to look at more of these later on. As I said, we spend a whole unit looking at them. But this is periodic. So a new type of relation we'll look at later on. Pretty neat. Let's look at the following two. Now, the last two, what you guys are going to see is that not every X value is going to give you a meaningful answer in a calculator. You might get an error message, and that's okay. Something we're going to learn in a few days is that, you can't plug any X value you want into certain equations. They kind of break the equations. And we'll want to be able to identify, what X values am I allowed to plug in? And actually later on, what Y values can come out. So let's look at this one. This is called the radical relation. Not because it's radical, it's just the term we give for roots like that, like square roots. But what's this rule saying? This rule is saying to get the Y values, you just do the square root of the X values. And decimal answers are okay for us just to fill up our graph. But give this a go. Maybe pause the video and try it. And think about which values gave you problems and which values gave you, something meaningful. So I'll let you guys do that. You can unpause when you're ready. But hopefully what you found was that when you did the root of a negative number, you just got an error. So you can just write error in here, or if you want to write like NA, that was a terrible N, NA. You don't get a Y value when you plug in those X values, you get an error message. There's no Y value and there's no point. But you can do the square root of 0. The square root of 0 is 0, and the square root of 1 is 1, and the square root of 4 is 2. And you get some in-between values when you do the square root of 2 and 3. So it's approximately 1.4, just for the sake of graphing it, and the square root of 3 is about 1.7. Not exactly, but for the purpose of seeing what the graph looks like, those will be good enough. So the 5 points we can sketch are 0, 0, 1, 1, 2, about 1.4, 3, about 1.7, and 4, 2. And what we get is a graph that looks something like that. And it's going to kind of be shooting up forever, but kind of leveling off. That's pretty neat. And there are no points when X is less than 0 because you can't root a negative number. So this is a really interesting graph. And the name we're going to give this one later on is the radical relation. So pretty neat. One last one for you guys to try. So this is called a rational relation. Just as a side note, the rational numbers, so in terms of like thinking about what types of numbers are there, you guys are familiar with integers. Integers are things like 2, 4, -5. They're just like basically whole numbers with including the negatives, 0, etc. A rational number is any number that is one number over another. So things like fractions are rational numbers. Whole numbers are rational numbers too, because 2 you could write as 2 over 1. So any whole number is a rational number. But yeah, so this is why we call it the rational relation, because it's one thing divided by another. This rule is saying to get the Y values, you do 6 divided by the X values. Now here I've chosen a lot of specific values for X. I chose values that are easily divisible by 6. So if you try all those guys, you're going to get a bunch of points. But maybe you're going to run into 1 or 2, or we'll see, that don't give you a meaningful value. So maybe even by looking at the equation, you can predict what X value might mess you up. But if you just want to start, you can pause the video, make this table of values, and we'll connect back with the graph. Of course, you can follow along with me. 6 divided by -6 is -1. And then we get -2. 6 divided by -2 is -3. And 6 divided by -1 is -6. 6 divided by 0, you get an error message. You can't divide by 0. Only Chuck Norris can divide by 0. 6 divided by 1 is 6, and then we get 3, 2, and finally 6 divided by 6 is 1. So if we plot these points, we get a really cool looking graph. -6, -1, -3, -2, -2, -3, and -1, -6. And we get, if we connect those points, kind of looks like this. And on the other side, we get 1, 6, 2, 3, 3, 2, 6, 1, and it looks something like that. And it never actually touches. There's no point at x equals 0. It can actually never hit. There's no y-intercept. It can never hit that y-axis. That's pretty neat. This is a brand new type of graph for you guys. It's called a rational relation. And we'll look more at these when we do some sketching later on. But the purpose of these investigations, and hopefully you're just getting back in the rhythm of things, get back using your calculator. We want to be able to be sure we're all rock solid. If I give you a relation, the equation of one, that you can make a table of values quickly and efficiently, and then you guys can make a sketch as well. So that's the intention. Excuse me. So what are we doing next? So of course, we're going to do some more review skills and prerequisite work. But in terms of our next lesson, this course is called Grade 11 Functions. So we better actually talk about what a function is. And that's going to be the topic for our next lesson. But until then, I hope you guys are staying well. Have a great day, and we'll see you soon.